Okay, in this video, I'm going to work on the last couple pages of our Chapter 3 review packet. So we have a few problems left, and I'm going to try to do all that's left in this same video. So our third video for Chapter 3 review. Okay, so just as a quick reminder, the front of the packet, do you remember it? It looks like this. Do you remember that matching? Okay, now let's finish that packet. So the word problem for number 31 says Mary is working at a coffee shop. And Mary earns $300 every week plus $2 for every cup of coffee that she sells. So what we're going to do is write down an inequality to determine the number of cups of coffee that Mary is going to need to sell in the week if she wants to earn a minimum of $500 for that week. Okay, so our starting price is $300 plus she's going to earn $2 per C, and C will equal cups of coffee. Now, if her goal is to make $500 that week, if she wants $500 to be the minimum, she wants to earn greater than or equal to the $500. Okay, so now what I'm going to do is subtract 300. So 2 cups of coffee needs to be greater than or equal to $200, which means she needs to sell greater than or equal to 100 cups of coffee. So she needs to sell more than 100 cups or equal to 100 cups of coffee. Okay, now number 32. There's a kite that's beginning to descend at 200 feet. It goes down at a rate of 12 feet per minute. Write and solve an inequality for how many minutes have passed if the balloon is below 10 feet. Okay, so starting value is 200 feet in the air. So if it's starting to come down, that means it is losing, meaning subtracting 12.5 feet per minute. And I'm going to use X for number of minutes. Now, if it's going to be below 10 feet, this is less than 10 feet. Okay, so now I'm going to solve for my X. I'm going to start by subtracting 200. And then I get negative 12.5x is less than negative, that's negative 190. Okay, now I'm going to divide by a negative 12.5. Okay, and now, since I'm dividing by a negative, don't forget you got to flip that sign to opposite direction. Okay, so negative 190 divided by negative 12.5. Okay, so here's my calculator. I get 15.2 minutes. Okay, so there we go. There's that one. Okay, now for number 33, a town's high temperature for a given month is 78 degrees and the low temperature is 51. So this is going to be one of those and inequalities where you have a least to greatest happening. So the lowest should come first, kind of like on your number line, the lowest comes first. So that's degrees Fahrenheit. And I'm going to use T for temperature. And then the highest would be 78 degrees Fahrenheit. Now, if it's a low of 51, it could equal the low of 51. So I'm going to make sure that both of those have equal to, because it could also equal the high temperature as well. Okay, now for 34, it says, a fundraising committee of 95 students is planning to raise money for Hurricane Irma. The committee is selling tickets to a barbecue. For the fundraiser to be profitable, the committee needs to sell at least 240 tickets. Now, due to safety codes, the facility can hold no more than 945. Okay, so here we go. If all 95 committee members have already purchased a ticket, write a compound inequality to model how many additional tickets they need to sell for the charity to make money. Okay, so there was a low constriction. They need to sell 245 to make a profit. Okay, and then max, they can sell 945. Okay, so they need to be selling some tickets. They have already sold 95 tickets. Now, if they've already sold 95 tickets, we want to subtract the 95 from the low and the high because Well, if 245 is what you need to sell minimum, but you already know 95 people are coming, how many additional tickets do you need to sell? So we need to subtract that 95. Okay, so 245 minus 95 is going to be 150. And then for the high side, 945 minus 95 is 850 additional tickets. So they need to sell a minimum of 150 and a max of 850 tickets. Okay, so there we go. Now number 35 here on my paper says for me to do an error analysis, and what I'm going to do is circle the error in the work shown at the right, then rework the problem to simplify correctly. Okay, so if this was my inequality, I would subtract 5 to the other side, which means I would get 10. Okay, now I would divide by the -2, which means my absolute value would be equal to -5. Okay, so far so good. Oh, here it is. Okay, when you have a negative outside here, what they should have done is stopped and then said no solution. And because absolute value, whatever you put in here, this should never come out to be a negative. So that's where the problem went wrong here. So they should have not had those two solutions. They should have stopped and said no solution because it cannot equal a negative. Okay, we have now actually solving some absolute values. So here we go. The absolute value of whatever's in here, just kind of to explain it, we could have had the absolute value of 2 that will come out to be 2, or the absolute value of -2 that will come out to be 2. And so I'm going to set my x minus 7 equal to the 2 that could have been in here to pop out to be 2. I'm also going to set x minus 7 equal to the -2 because the absolute value of -2 will pop out to be +2. So now these are my two equations that I'm going to solve. So I'm going to add 7 here, and I have one answer of 9. And then if I add 7 here, my second solution, or -2 plus 7, would be 5. So those are my two answers I could get for that. Okay, now for number 35, what we need to do is get rid of our constant term before our multiplier term in the front. So I'm going to start by adding 12 to both sides. Okay, 8 plus 12 would get me 20. Now what I'm going to do is divide both sides by 5. And I get 4. Okay, now since I have my absolute value set equal to a positive, I know I can set up my two equations. So the absolute value of 4 will come out to be 4, and the absolute value of -4 will come out to be 4. So I'm going to set this x plus 3 equal to 4 and -4, because x plus 3 could have been 4, but x plus 3 could have been -4. Okay, so now subtract 3. X could have been 1. Subtract 3 again. X could have been -7. There we go. Okay, now last two. Here we go. For this question here, I'm going to start by subtracting 9. So the absolute value of 3x minus 7 would be set equal to -8. Now, an absolute value will never pop out to be negative. These are like positivity bars. So whatever problem you have going on in here, it should never come out to be a negative. So I'm going to stop here and put no solution, because the absolute value of 8 would come out to be +8, but the absolute value of -8 pops out to be +8. So it's impossible to get -8. So no solution for that one. Okay, last one here we go. Subtract 5 technically. Okay, so I'm going to start with subtracting the number term to the other side, and I get -8. Now don't jump the gun here. I know there's a negative, but there's also a negative here. So when I divide by -2, that negative is going to cancel out and become a +4. Now I can set up my two equations. The absolute value of 4 will become it will become positive 4. So x minus 1 could have been 4. Or you could take the absolute value of negative 4, and that will still pop out 4. So my x minus 1 could have been negative 4. Okay, so now let's solve by adding 1. I get a solution of 5, and I'm going to solve by adding 1 again, but this time I get negative 3. Okay, there we go. I hope these videos have helped you out, and let your teacher know if you have questions. Reach out. We want to help you.